Okay, so for our first example, it says, you are testing the claim that the proportion of men who own cats is significantly different than the proportion of women who own cats. You sample 150 men and 40% own cats. You sample 200 women and 80% own cats. Find the pooled proportion, P bar, as a decimal rounded to 2 decimal places, and then it gives us some direction. To do this, first compute the number of successes of men and women. They need to be integers, so round if necessary. And then we don't really need to do a hypothesis test for this one. So I have two different populations, right? So I have men, so this could be P1, and women, right? P2. Okay, so let me just write the formula here, right? So P bar, this pooled proportion, is x sub 1 plus x sub 2 over n sub 1 plus n sub 2. Okay, well, I know what n sub 1 and n sub 2 is, right? That's the sample size. So I have 150 men and I have 200 women, right? So that'll be my denominator. Now I need to figure out the number of successes. So if I take, right, 150 men, now 40% own cats, right? So 150 times 0.4. So I end up, right, with 60 that own cats, right? So that would be, this is equivalent to x sub 1, right? The number of successes. We want to do the same thing with the women. So 200 times 0.8. So 200 times 0.8, right? I get 160. And that x sub 2. So I have 60 plus 160. So you do want to, right, so you can plug this in, put it in parentheses, 60 plus 160 divided by 150 plus 200. And so it says round to 2 decimal places, so my pooled proportion for this one would roughly be 0.63, right? So it's taking proportion, right? It's taking basically the proportions, the number of successes, the total sample size, taking that into account to find this pooled proportion. All right. So example 2 now, we're going to actually look and do a full hypothesis test. So let's take a look at this one. It says researchers conducted a study to find out if there is a difference in the use of e-readers by different age groups. Randomly selected participants were divided into 2 age groups. In the 16 to 29-year-old group, 7% of the 628 surveyed used e-readers, while 11% of the 2,309 participants 30 years old and older use e-readers. Test the claim using a 2% significance level. So what I like to do first is just identify the two different populations, right? So 16 to 29 years old. And then I have 30 years, right? 30 years plus. Okay, so we know, right, 7% of, right, 628. So if I take, right, 7%, so 0.07 times 628, that's going to tell me the number of successes, right? And since we identified the 16 to 29-year-old first, I usually just say that is population 1, right? So proportion, we'll see x1 for this one. So 0.07 times 628. So we do want to round, we want an integer. So we don't want 43.96. So we would just say 44. All right, so this is x1. And if we do the same thing for the other group, right, we have 11% of 2,309, so 0.11 of 2,309. So 0.11 times 2,309. So we'd say roughly 254, right? And this is going to be x sub 2. Okay, so what I want to do next, right, is I want to identify what my null and alternative is going to be. Okay, so since we're looking at proportions, right, population proportions, and we have 2, So P sub 1, right, is equal to P sub 2, right? This is always sort of our null. Now our alternative will also have P sub 1 and P sub 2, but now we have to determine, is it equal to, greater than, less than? So let's see what it says, right? It says, conducts a study to find out if there is a difference in the use of e-readers by different age groups. So it's not saying one group is more than or less than, it's just saying, is there a difference? So we would say not equal to, and this is going to be a two-tailed test. Okay. So I should have enough information, right, to go through and figure out and type this into my calculator. The only other thing I might want to identify is just the level of significance. So alpha is 0.02. So we will hit our stat button. We're going to go to tests, and we want the two proportions z test now. We'll hit enter. All right. So x sub 1, right, is, let's see, x sub 1 is 44, right? And so we want it as a whole number. If you try to put it into the decimal, you'll get an error. Out of 628, right, that's n sub 1. X sub 2 is 254. N sub 2 is 2309. Now there is a way, so like for x sub 2, you know, we typed 0.11. You could do this in your calculator. 0.11, right, times 2309. Right, it'll write it as a decimal, and then you can go back up and do that 254. Okay. And then we have the not equal to for the alternative. Don't really care about the color, and we'll hit calculate on that one. So I have a couple things, right? I have the standardized test statistic, right? That z, so negative 2.94. I have my p-value of 0.003. Now, if you think of this p hat, right? P hat is also known as p bar in our calculator. So this would be the pooled proportion. So if you ever need that and you just have x's, you can actually figure that out too. Okay, so I have everything I need from my calculator to complete my hypothesis test. So we're going to compare, right, the p-value with alpha. So I take 0.003 with alpha. Now, we did this before with our hypothesis test, but I know it's been a little bit. So we recognize that alpha is larger, and anytime alpha is larger, we are going to reject the null hypothesis. So reject the null hypothesis. Okay, so because we do that, we're going to start off our, right, if we write a conclusion, well, we could say there is sufficient evidence to suggest that there is a difference in the use of e-readers by different age groups. Sometimes they may say like what the level of significance is, so they could say at the 2% level of significance there is sufficient evidence, but that's sort of all the different pieces of my hypothesis test, right? So we definitely always want to write the null and the alternative. We want to find, right, our standardized test statistic and our p-value, right? Sort of do our conclusion with our p-value, whether we're rejecting or failing to reject, and then we're writing this conclusion. Okay, so those are sort of the pieces of my hypothesis test.